Welcome everyone. In this presentation, we will see some steps related to the workflow for the sample preparation, and we will focus our attention to the vessel handling, then the microwave digestion system, and the sample filtration. So we move, as you know, the sample preparation workflow, it's made by several steps, starting from the weighing of the sample till the analysis by your ICP systems. And in the middle, there are different steps to consider in order to have a reliable and robust analytical sequence, analytical methods that allow you to get reliable final data. So there are first two steps that we have seen other presentations. For example, the use of the ultra pure acids, then how to handle the acids. And now we move to focus our attention to the vessel handling. Since the handling of the vessels, and for the handling, I mean everything related to the opening and closing of the vessels, takes some challenges. The first challenge is related to the productivity, because the time you need to assemble the vessel, to prepare the rotor, especially if you have a lot of positions, this requires time. Of course, the time have an impact on also to the cost for the analysis, as reduce the productivity. And it is important to have in a laboratory a good way, a reliable way to properly close the vessel, but that also reduce that time of preparation of the vessels and the rotors. Other challenges are related mainly to the operator time, as we have seen, and also to the safety, because as I said to you, a hand close of the system of the vessels in many cases is not sufficient, or it's easy to make mistakes, especially if you have a lot of samples to prepare, if you have rotors with a lot of positions. So having an automated way for closing the vessels, you have a precise way to hermetically seal your vessels without any mistakes. So there are different solutions for handling the vessels. Later, I will show you a little bit more in details how this works. But just to give you an idea, for our rotors and for our vessel, we have automated systems like the ones that you see in this slide, that is called EasyCap, to automatically close the vessels. This is a very good way to speed up the closing of your vessels and then do it in a very precise way. So you are 100% sure that your vessel is hermetically closed. The vessel handling, it's an important part, and it is immediately connected to the microwave digestion systems. If we focus our attention to the methods available today for digestion of environmental samples, and of course, if we consider the EPA methods, there are mainly three methods used for the sample preparations. The EPA 3005, the 3010, and the 3050. These methods are designed for the digestion of waters or soils and sediment samples, and all of them requires the use of a hot plate or a hot block for the sample preparation, for the digestion of your samples, for the dissolution of the elements into the acid mixture. The use of hot plates and hot blocks requires long time. Normally the digestion takes several hours, and this creates other challenges, not only related to the time, so to the productivity, again, of the sample preparation, but also challenges related to the quality of the digestion, where the hot plates works with open vessels, and then you have loss of volatile elements like mercury, just to that is a very volatile element, and then working with open vessels, the maximum temperature that you can reach is the boiling point of the reagents. And then the EPA methods require the digestion, request to perform the digestion at a very low temperature, around 95 degrees. And this, of course, increase the time of the digestion, as we have seen, but also create, let me say, it's not very efficient to fully dissolve all organic particles, all organic materials that are present into your samples. And if you do not have a proper method to fully digest organic particles, organic matters, then you risk to have interferences during the analysis, because the carbon that's still present, so the organic particles that's still present into the solutions, create interferences, create false positives, and then you have this means that you have to reprocess the digestions if the data are not correct, and then you have to rerun the digestion process and then the analysis. The other things is related to the blanks, because as you can imagine, the vessels are open, and of course it's easy to contaminate the reagents, to contaminate the sample, and of course this means that you have an increase of the level of the blanks. And of course, the level of the blanks is influenced by the external environment, especially in many laboratories that work with hot plates. Probably this is also your case. Works, of course, with the hot plates under a fume hood, and the fume hood have can contaminate your solutions, especially if they are if on the metal parts of the fume hoods are present some rust or some corrosion that creates some metal particles that falls into your vessels and then increase the level of the blank. So all these challenges are very important challenges that can really influence your final data and increase the time of the sample preparation. And the solution basically is with the use of microwave digestion systems. So the units that are available for digestion of environmental samples are basically two. We have the rotor-based system, that is the one on the left, the ethos-up units that we provide, or the single reaction chamber system, that is the one on the right. That is the like the ultraweight 3 that we provide. Now, today we focus our attention only on the rotor-based systems. If you need more details about the single reaction chamber, I invite you to contact directly Milestone, or to have a look to our website, or to anyways stay in contact with next webinars where we will speak about this technology. However, just focusing on the rotor-based system, it's a microwave oven, as you can see in that picture, that has a cavity where inside we introduce rotors that can work with different vessels. So we have three different kinds of rotors. We have the Maxi 44 high throughput rotors, the Maxi 24 high performance rotor, and the SK15 high pressure rotors. All of them are good rotors and suitable rotors for digestion of environmental samples. Since environmental labs normally requires to have to perform a digestion of a lot of samples per day, so normally environmental labs requires a high productivity. What we normally suggest is it's the use of the Maxi 44 rotors, where basically you have 44 positions that can work simultaneously, and then each vessel is designed to reach very high temperature conditions and a pressure of 35 bar. That is enough pressure for digestion of all kind of environmental samples. The operating temperature of this rotor is normally 200 degrees. So you can already see from this slide that you can perform digestion at much higher temperature than 95 degrees. And this, of course, brings some important benefits for your digestion process. The benefits are related mainly to the productivity, then because the digestion from hours takes minimum 1 hour of your time, of the time for digestion, so you can in 1 hour digest up to 44 samples simultaneously. And then, of course, you reduce the level of the blanks because the vessels are hermetically closed, and the materials that we use are high purity material, very easy to clean. And then, of course, you reduce or you eliminate any loss of the volatiles, because, as I said, hermetically closed vessels helps to maintain everything into the vessel, and the vessel goes under pressure, and it's basically not possible to have losses of elements like mercury, and normally the recoveries are very, very high. Having said that, the use of the microwave, of course, it's integrated in the EPA methods, and the EPA method, and there are EPA methods that give you the right procedure to perform digestion of aqueous samples and soils, sediments, materials using microwave systems. So there are already methods for the use of the microwave systems, and of course the microwave brings all the benefits that we have seen before. The other part that is again connected to the digestion is the filtration. The filtration, it's a step that is recommended only if you are not looking for the complete digestion of the samples. And normally when you digest soil, you don't need the complete digestion of your samples. And the filtration, it's mandatory before the analysis, because you cannot introduce in your ICP a solution that it's full of solid particles inside. Normally, the filtration is performed with funnels and paper filters. Be aware that there is other ways to do the filtrations, because consider that the filtration brings some challenges, again, related to the productivity. Normally, when you filter a solution that is full of particles, like a soil, like a sediment, it requires time. It requires time because the particles reduce the porosity of the filters and then increase the time of the filtering. Then, of course, if you perform the filtrations in a classical way, so with the funnel and the paper filter, this requires space in the lab, space under the fume hood. And of course, it's important to avoid, this is important to avoid the exposure of the analyst, the exposure of the users to the vapors, to the acid fumes that goes out from these filters. So there are all these challenges that can be solved by using a dedicated system for filtration. And Milestone provides this unit that it's the name of this unit is SFS24, where you have 24 positions that simultaneously perform a fast filtrations, because this unit is able to goes under vacuum, and then thanks to the vacuum speed up the filtration by speed up the filtration process. So you simply pour the final digested solution on the top, from the top of the vials here, and then you collect here all the final solutions ready for dilutions and analysis. This unit is compatible with many different kinds of vials, round bottom flask that normally you use in the lab for dilutions and analysis. Okay, so we have seen how the automated system for closing the vessel, the microwave digestion systems, and the automated system and the vacuum filtration systems can have an impact on especially on the productivity of the analysis for environmental samples. The impact is positive not only for the productivity but also for the digestion quality. So especially this is related to the use of closed vessels during the digestion process, where it's basically impossible to have external contaminants or to have loss of volatiles. And then, of course, you have a very reduced, or anyway, minimize risk to have to reprocess the digestions and the analysis, because with a almost automated way to digest your samples, you have much less risk to do errors during the sample preparations and analysis. And another important aspect is related to the safety for the operators, because we work with systems that are automated and then can reduce a lot the the exposure of hazardous acids, vapors of the operator, or reduce, as I said before, any errors during the run. So the presentation is now finished, but I want to give some details related to the sample preparation, to the microwave use, just showing you some few things related, some few steps for the sample preparation. So here I have all our rotors. We have the high pressure rotor, the high performance rotor, and the high throughput rotors. That is the one that we recommend for the digestion of environmental samples. And I move now the camera a little bit closer just to show you the vessel of this configuration. This is the vessel. You can put the vessel directly on your balance, and then you can load the sample inside here, and then you can add the acids. The acids can be added manually or using the easy fill system. And then the closure is like this. So we have this cap to put on, and then we have this cover to close, hermetically close. Consider that all our vessels have are designed in order to have a control of the internal pressure. So while you are eating the solutions, of course, you create a pressure inside. The maximum pressure you can reach inside this vessel is 35 bar. But if you pass that limit, if you go over 35 bar, the cover is designed in order to open a little bit the covers, basically, and release the fumes. So there is an automated regulating system that regulates the internal pressure of your vessels. And this is available for all vessels and all rotors that I showed you before. So you have seen that the closure of the vessel is pretty easy by hand. And as I said, it's possible to perform this using an automated system, using the easy cap system. So basically you have to simply put this here, then press this, and that's all. Very easy and very fast to use. Okay. This is the rotor, and when the rotor is complete, it's possible to load it inside the microwave oven. The microwave oven, oh, let me move the camera again. Okay. Okay. So the microwave oven, as you can see, it's quite big, so it's possible to introduce the vessel directly here. So it's possible to work with rotors like this one with 44 positions. As you have seen, I moved the rotor like that. But if you want, you can keep the rotor body inside here, and you can just slide it out when you have to remove the vessel or when you have to introduce that. So normally when I prepare this rotor, I take the vessel, load the sample and the acids, then I close with the vessel with the easy cap system, and then I load the vessel like this. When I complete the loading, I slide in the rotor in that way. That is very, very easy and very fast to do. After that, we can start the digestion process. And the digestion process is driven with this software. It's a touch screen terminal where you have a direct control of the temperature during the run. The temperature is measured by an infrared sensor that is on the bottom of the unit, and then reads the internal temperature of all the positions. So you can read the internal temperature of all the vessels. The rotor, of course, during the run is rotating, so we measure the internal temperature of all the positions, and then the unit regulates the amount of energy according to the profile, to the temperature profile that you have designed in the software. Sorry. The software, it's also designed, it's also has inside a built-in library with the different methods that you can use for the digestions, that you can upload on the software, and then you can use to perform digestions. There are methods for environmental samples, and there are also official methods. Let me move a little bit the camera closer so you can see it better. Okay, so I hope you can see. Yes, now yes, it's basically there are official methods, and here you can find the EPA methods that are designed basically to work with the macro-waste system. For each method, you have also information about the sample amount and the reagents to use for the digestion. So this is a very fast way, basically, for the sample preparation for the digestion of all kind of samples, of all your samples. Okay. So we have seen how these steps, the automated closing systems, macro-waste digestion systems, and the filtration systems can basically have a big impact on the productivity of your laboratory and on the quality of the digestion and the final solutions that you obtain. These steps are very, very important if you are looking to speed up the analytical process and to have a better quality of your final data. And these, of course, let's say, have another positive impact on the laboratory that is related to the space of the lab, because all these steps can be done in a very small space. Consider that the macro-waste system, as you can see, is not installed under the fume hood, so can be installed outside a fume hood, and then you can have the easy cap close to the unit, and then close the vessel, put the vessel inside, and run the digestion in a 1.5 meters space, 1.5 meters space of your bench, basically. So it's not doesn't require much space. So that's all for the moment. If you have any questions, please write all your questions, and then we will answer to you in a second moment. Thank you very much for your attention, and see you in the next milestone workshops.